Hi, welcome to another session of Circuits and Networks based upon the views as well as likes. I have thought of dealing another topic, that is mesh analysis and node analysis. Many students they have question that how to select the direction of the loops. Either we have to show taking clockwise directions or anti-clockwise directions. How to select the node. So this is the common problem faced by most of the students while dealing with the mesh analysis and node analysis. Thinking of that, I thought of taking another session under mesh analysis and node analysis. So here we are going to see few numericals, and later on we are going to see typical numericals based upon mesh analysis and node analysis. Then if time permits, we'll also solve the problems which are coming in competitive exams like GATE and engineering services exams. So this is a very important topic, how to deal with the mesh analysis and node analysis in order to determine the loop currents, branch currents, or the power developed across an element. So all these things are very important, and this particular class will give you the basic model how to solve a given mesh analysis problem. So you can see we have to make use of KVL, Kirchhoff's voltage law, and Kirchhoff's current law, individually dealing with the mesh analysis and node analysis. So let us start with the solving of problem one. You can see here there is a two loop in a particular circuit. You have two loops where you have 5 volts, 3 volts. Observe the directions of the voltages. On the left side it is positive negative, on the right side also it is positive negative. One is 5, another is 3, and 2 4 8. This particular arrangement of resistive network is called a T network. Sometimes it is also called as a wine junction network. So on left hand side you have 5 volts, and on right hand side you have 3 volts. So how to solve this particular problem? We need to find out the current in 8 ohms. So I'm considering loop 1 and loop 2 for the given circuit, and in loop 1 I'll be having current I1, whose direction I have taken here as clockwise. Similarly, another loop current I2, I have taken this direction also in clockwise. So applying KVL to loop 1 and loop 2 respectively. So first I'm going to apply for the loop 1, and then I'm going to apply for the loop 2. So you have 5 volts here and you have negative sign over here. So I consider this particular analysis according to my own way, by reading all different techniques. This technique will give you a better way to get the solution. So you have a loop and you have the voltage 5 volts, and this current I1, when it goes through 2 ohms, it develops a voltage across 2 ohms. Similarly, this current I1, it is flowing through 8 ohms, and the 8 ohms is shared between loop 1 and loop 2. So it will have the impact of both the loop currents, and therefore the voltage will be developed across 8 will be the combination of 8, that is a resistance, multiply with the difference of these two currents. Why the difference of these two currents? Because I have taken loop 1 and loop 2 both the directions in clockwise, and when the current has to flow through 8 ohms, that is called as the branch current, it will have the difference of these two currents. Now this is based on the assumption that I have taken the loop current directions in clockwise. So minus 5 on the path, you have minus 5 volts. Then when current travels to 2, it has 2 resistance value, and I1, it is the value current which is flowing here. So voltage law of Kirchhoff states that the algebraic sum of the voltages in a closed circuit is a 0. So that is why 2 with I1, it's a voltage drop across 2 ohms. Then you have 8 ohms, and the difference of the currents I1 minus I2. Why it is I1 minus I2? Because while considering loop 1, I'm assuming the loop 1 to be the dominating loop, and the next loop, when I'm considering at the instant of loop 1, it is least dominating. That's why I have taken I1 minus I2, which is equal to 0. So this equation satisfies Kirchhoff's voltage law. With this, I will shuffle the equation in this fashion, that is 8 plus 2, that is 10I1 minus 8I2 is equal to 5. Now this we'll treat as equation 1. Now once we are done with this equation 1, The same logic will apply for loop 2. So you have 8. As I told you, when you are going to consider the loop, you have to assume the loop to be at the dominating condition. So loop 2 at the dominating condition will have current I2, and at this instant of time loop 1 current is least dominating when I'm considering with loop 2. So 8 I2 minus I1, it becomes a voltage drop plus 4 I2. Then on the path I'm getting 3 volts, so there is a given voltage source, so plus 3 equal to 0. So again reshuffling this equation, I'm going to get minus 8 I1, 8 plus 4 12 I2. Here you have plus sign, so when you are going to shift it to the right hand side it becomes minus 3, and this we are treating as equation 2. With this we have two equations with two known parameters and unknown parameters. So the parameters which we have to determine is the loop currents I1 and I2. So you can substitute these values in your calculator, or you can go for mathematical analysis, take the common value, just remove the I1 term or I2 term with this equation I2, get one term in terms of another and substitute in one of the above equations, that is equation 1 or equation 2. You can get the values of I1 and I2. So for your easiness, I have solved this and I obtained the value of I1 to be 0.64 amperes and I2 as 0.17 amperes. Now these are the value of the loop to loop currents. What is the main motive? We have to find out the current in 8 ohms. So the value of the current in 8 ohms will be I1 difference I2. Moreover, you can see I1 direction and I2 directions. We have assumed here both are in clockwise. So the value of current in 8 ohms will be I1 minus I2. Why? Because current has to flow from this point to this point. So higher to lower. So I1 is assigned with the higher conditions of the voltage and lower conditions of the voltage is at the bottom. Then only the current will flow through the branch. So I1 minus I2. So with this, substituting the value of I1, I2, we are going to get the value of current in 8 ohms, which is equal to 0.47 amperes. So this is a very easy approach to obtain the branch current, that is 8 ohms is known as the branch current value. So whether we have done this approach in a right way or not, we can cross-examine. So you can see again I have taken the same circuit with loop currents as loop A and loop B. Just to distinguish the currents from the previous values, I have selected as loop A, loop B. So loop A, direction of the current I have taken in clockwise, whereas this loop B current, you can see from the previous case, I have selected in anti-clockwise. If this is true, how to solve the problem using mesh analysis? So this we are treating as second solution. So we are going to apply KVL to loop A as well as loop B. Loop A we are considering clockwise direction and loop B we are considering as anti-clockwise direction. So we are going to start with minus 5 plus 2 IA plus 8 IA. Now you can see 8 which is placed between these two loops. This is the branch resistance shared by two loops. So here the current is coming from top to bottom. On the right hand side also it is coming from top to bottom. So left and right you can see from top to bottom the currents are in turn. And that is why we have taken the sum of the currents in this particular case. Now this assumption, it is based upon the direction of the currents what we have considered for loops. So with this you have to reshuffle the equation or rearrange the equation, then you're going to get as 10IA plus 8IB is equal to 5. This we are treating as equation 3. The same logic I'm starting with minus 3 plus 4 IB plus 8 IB plus IA is equal to 0. So with this I'm going to get another equation as 8IA plus 12IB is equal to 3. Now just solve these two equations, equation 3 and equation 4. You're going to get the value of IA which is equal to 0.64 amperes and here IB is equal to minus 0.17 amperes. So unlike in the previous case we have taken two loop currents in the clockwise and fortunately we got the positive currents in this case, and here one current we have taken clockwise, another current we have taken anti-clockwise. The current which we have taken anti-clockwise, it has given the value as negative. So with this, the value of current, branch current in 8 ohms will be equivalent to IA plus IB, or you can also say that IB plus IA. Both will give you the same result. So you have to just substitute the values of IA and IB. So I have substituted the value of IA, which is 0.64, plus here we got the value of IB as minus 0.17 amperes. Based upon this analysis, substituting the value of IB, then also we're going to get the current as 0.47 amperes. So this is how you can introspect this kind of results. You can also take the loop 1, loop 2, both the current directions in anti-clockwise. Then also you observe the result. This will give you the same answer. In some cases, you may get the negative symbol of current. It indicates that the directions what you have obtained and to the directions which the problem it is mentioned, they are different. So you do the other two approaches. The first approach, I have taken both the current directions as clockwise. Another approach, I have taken the direction of the current as one as clockwise, one is anti-clockwise. In third case and fourth case, you can take anti-clockwise directions of the current, and in the fourth case, you can take anti-clockwise direction IB and anti-clockwise direction of IA in opposite side. So then also you will get the same result. So this is how you solve the branch current problems or mesh analysis. Whether we have done right or wrong, this also can be examined with the help of uh, node analysis. So what answer we got using mesh analysis with these two conditions? With these two conditions, we got the current to be 0.47 amperes. So whether we have done right or wrong, let us examine with node analysis. For node analysis, I am selecting the same circuit and I am taking the node voltage as V. You can see node is a point where more number of branches are connected. From this node to this node, you have one branch which is having 5 volts in series with 2 ohms. So this is considered as one branch. You have 8 ohms and this is another branch. And you have 4 ohms in series with 3 volts. This is another branch. So node is a point where you have more number of branches. So applying KCL to this particular node. So V I am considering to be at higher potential, and below 8 ohms and below 5 ohms, below 3 ohms, you have negative symbol. So this we consider as the reference node, taking the value of voltage to be 0. So one at higher potential, one at lower potential. So V minus 5 by 2, this becomes one current, one branch current. Then you have V, you don't have any voltage over here, so V minus 0 by 8, which is nothing but V by 8, plus V minus 3 by 4 is equal to 0. So this is how we can obtain the equation under node analysis. Just simplify this equation. Take voltage V common. You have 1 by 2, 1 by 8, 1 by 4. I have taken the values and I have taken V as common, which is equal to, you have on the left side minus 5 by 2. Take it on right side, will be 5 by 2. Similarly, you have on the left side minus 3 by 4. Take it to the right side, it will be plus 3 by 4. Just solve this equation. So I have taken the LCM and I have solved the value of V, which is obtained to be 3.714 volts. Once I obtain the value of voltage, then I can obtain the value of branch current under node analysis as I is equal to V by R. So this is the current what we required. V by 8 what we required. Now this is under node analysis. So we have voltage as 3.714 divided by 8, which is going to be obtained at 0.4642 amperes. Now you can cross check this answer. 0.4642, it is almost equivalent to 0.47 amperes. So whether we have done with solution 1, solution 2, or whether we have employed node analysis, we got the same result. So this is how you have to cross check for every problem. Then once you're getting the same answer, then you are going to get the confidence that whether you employ mesh analysis, node analysis, wherever you need to determine the value of current, voltage or power, you're going to obtain magnitude value as same. Let us go through the next example. See, this is the same problem. You have 5 volts, 3 volts, 2 ohms, 4 ohms, and 8 ohms. The main problem is that the voltage source is reversed on this particular circuit. On the left, you can see in the previous case you have positive sign on the top, negative sign on the bottom, but here you have negative and positive reversed. So definitely the answer is going to get changed. So the same analysis I'm going to apply what we have employed for mesh analysis under solution 1. So applying KVL to loop A, you have minus 5 as it is, plus 2IA plus 8 IA minus IB equal to 0. Same approach. With this, you're going to get the equation 1 as 10 IA minus 8 IB is equal to 5. Now apply the KVL to loop B. You have 8 IB minus IA, same approach, plus 4 IB, same approach. Now in the previous case, you can see plus was assigned at the top and minus was assigned at the bottom. So we have taken plus 3. But here you have minus 3 on the top and plus 3 symbol, plus symbol is given to the ground. So I'm taking minus 3 as it is equal to 0. So this equation can be reframed as minus 8 IA plus 12 IB is equal to 3 amperes. Now just solve these two equations, compare with the previous solution and solve these two equations. I'm going to get the value of IA is equal to 1.5 amperes and IB is equal to 1.25 amperes. What we need to require to calculate, we require the current which is in 8 ohms. So 8 ohms is nothing but IA minus IB. Just substitute the value of IA and IB which is equal to 0.25 amperes. I hope you understood this approach. Let us cross-examine the result with another technique, that is a mesh analysis only, but taking the direction of the currents in different way. You can see I1 loop I have selected in anti-clockwise and I2 I have selected in clockwise. So according to this approach, what happens? Applying KVL to loop 1. So I'm starting from 8. So 8 I2 plus I1, because from bottom both the conductors are entering, plus 2 I1 plus 5 is equal to 0. Isn't that simple? Just rearrange this equation, you are going to get the equation 3. And same analysis, KVL to loop 2, I am taking from 8 analysis, 8 I2 plus I1 or I1 plus I2, whatever it is, plus 4 I2, this is the another drop over here, minus 3 equal to 0. So this we are treating as equation 4. Just solve equation 3 and 4. We are going to get the value of I1 is equal to minus 1.5 amperes and I2 is equal to 1.25 amperes. And we are going to take the value of I8 which is equal to I1 plus I2 based upon the direction of the currents over here. So which is equal to minus 1.5 plus 1.25 which is equal to minus 0.25 amperes. Now you check these two results. Check the magnitude of the currents. Magnitude of the current is same. Okay. Only the direction of the current is changed because the direction of the loop currents we have changed. So that is why we got the negative symbol. So magnitude of the current is not going to change. Only the direction of the current is going to change based upon the loop what you select, whether you are going to select in clockwise or anti-clockwise. So this is how you solve this problem. So whether we have done right or wrong, let us employ KCL, that is node analysis. So I'm taking this to be at higher potential. So V minus 5 by 2, that is the first branch current. V by 8, there is another branch current. But this you can see, in the previous case it was V minus 3 by 4. Now it is V plus 3 by 4. So just rearrange this equation and you're going to get the value of V to be 2 volts. Once you obtain the value of voltage, calculate the value of current. I told you branch current would be equivalent to I is equal to V by R. So here we need to find out the value of current. So that is V by 8 which is equal to 2 by 8 which is equal to 0.25 amperes. So this is the same value of current which we have obtained using solution 1 under problem 2. So this is with mesh analysis and the same approach with node analysis. So this is how you need to check the values of magnitude of current using mesh analysis and node analysis. Let us go with another problem. Here you can see you have 6 amperes, 4, 2, 3 values of resistors arranged in T network, and another voltage you have 5 volts. So one is current source, one is voltage source. So apply mesh analysis. When you're going to apply mesh analysis, you have to observe that this is the current source. So the current source in the series will dominate, and the same 6 amperes it is coming to 4, whereas this 6 amperes when it goes to 3 it becomes the branch current. So the value of current will be in 3 ohms will be IA difference IB, or I1 difference I2, whatever you can do. So here luckily we have the source current as well as the current which is flowing in loop 1 as same. So IA is equal to 6 amperes. So take this one as equation 1. Just apply KVL to loop B. So 3 IB minus IA plus 2 IB plus 5 equal to 0. Substitute the value of IA over here. Then you are going to get the value of IB which is equal to 2.6 amperes. So once we are done with IA and IB, we can easily get the value of. So what is the first question? Obtain the value of current in 2 ohms. So the current in 2 ohms is nothing but the current which is flowing in loop IB. So this is the same current, that is 2.6 amperes. And we have to find out the voltage across 3 ohms. According to Ohm's law, V is equal to IR. So R value is 3 and the value of current in this particular loop will be IA minus IB. So 6 minus 2.6 will give you the value as 3.4 amperes. Just multiply this 3.4 amperes with the resistance, which you are going to obtain the value as 10.2 volts. So unlike the previous two problems we had the voltages on both the sides of the circuit, and here you have one current source and one voltage source. The arrangement it is shown. The same problem, if at all you take the direction of the loop currents in different fashion. So here I have selected the value of Ix, which is almost equal to IA, that is 6 amperes. Applying KVL to loop 2. Now you can see in this particular case, unlike the previous condition, I have selected the loop direction of the IY in anti-clockwise. So I'll start with minus 5 plus 2 IY plus 3 IY plus IX equal to 0. Just substitute the value of the 6 amperes in this particular equation. So you have IY and you have IX which is 6. So 6 into 3 will become 18. So that's why you got the value as 18. You have 3 plus 2 which is 5 IY, and this 5 has reached to the other side of the 0. So it becomes positive 5. So IY you are going to get as minus 2.6 amperes. I hope you understood how you got the value of IY which is equal to minus 2.6 amperes. Now once we obtain the value of IY, just obtain the value of branch current I3 which is equal to IX plus IY. Substitute the value of IX and IY, and again we are going to get the value of I3 which is equal to 3.4 amperes. Once we are done with the branch current, calculate the value of voltage which is 3.4 into 3, that is 10.2 volts. So in these two solutions you must have seen the result what we have got in the name of magnitude, it is same. So in the previous case we got the same values. So let us examine with node analysis, that is taking the node voltage over here, and this is the current we need to find out. So applying KCL to this particular circuit, minus 6 is the value of current which is coming towards the node V. So minus 6 plus V by 3, another branch current, plus V minus 5 by 2 is equal to 0. No need of taking this 4 because current in 4 will remain the same. So that is why we are taking direct 6 which is coming towards the node, and since it is coming toward the nodes it is taken as minus 6. So again just solve this particular equation. You are going to obtain the value of B which is equal to 10.2 volts. Now fortunately this answer is the same answer what we have obtained using mesh analysis, 10.2 volts. So same answer we got. Now what is the current required? We need to evaluate the current which is flowing through 2 ohms. So which is nothing but V minus 5 by 2. Now that is the value of current in 2 ohms. So just substitute the value of V, that is 10.2 minus 5 by 2 which is nothing but 2.6 amperes. Now you can see in mesh analysis we have taken for this particular case in anti-clockwise, that's why the direction is negative. But solution 1 we have obtained the same answer, that is 2.6 amperes. So I hope you have understood the basics involved in order to solve the problem using mesh analysis and node analysis. So whether you employ mesh analysis or node analysis, the magnitude of the current required in a particular branch, it will always be the same. This is the conclusion what we can make with this particular session. So I hope you like my video. Share and subscribe among your friends, and plus please press the bell icon for the future notifications. Thank you.